Hey everybody, today we are going to see about canonical cover. So for knowing this canonical cover, you should have already studied the theory of functional dependency, how to calculate F closure and how to calculate the attribute closure. So the next stage is the canonical cover. In the canonical cover, what we are going to do is, whatever the functional dependency is given, that we are going to reduce. That is, canonical cover is also called as the minimal cover. So we have to reduce the functional dependency. Here reduction means we can combine using union law. After that, if any extraneous attribute, what do you mean by extraneous attribute? You can see that you have A and B here. Similarly, in the beta side you have B and C, in the alpha side you have A and B. So this two variables, either one is removed, still the functional dependency could be preserved, then we call it as an extraneous variable. So when you remove a variable, still you are able to find the same functional dependency on the set, then you can say it is an extraneous variable. So you can remove the extraneous variable on the alpha side, also you can remove the extraneous variable from the beta side. So we will start with removing from the alpha side. So for a given function set of functional dependency, first we apply the union rule. You can see that A tends to BC, B tends to C, A tends to B, AB tends to C. So in this you can see A tends to BC and A tends to B can be combined and written as A tends to BC, because we have right hand side both are A. So it could be written as A tends to BC. After that you can write BC and AB tends to C. So this is my new functional dependency. So after finding the new functional dependency, we will go on for attribute closure, for finding the attribute A which is extraneous in alpha. So for finding which is extraneous, either you could search for this or you could find this is extraneous. So we are going to calculate which is extraneous. So for that we have two rules being defined on our formula. First, you should calculate alpha minus A plus. That means attribute closure. First, from the alpha side you subtract whichever is extraneous. A is called as the extraneous variable. So whichever is extraneous, you are going to remove that, and after that you are going to calculate the attribute closure on F. So this is our F. On F we are going to calculate. Then we are going to check that alpha minus A plus contains beta. If you, after removing an extraneous variable, still you are able to get the beta side, then you can say that it's an extraneous variable, you can remove it from the set. So we will go on with the example. So you can see here which one is having alpha side. Yeah, you can easily say this is equation which has an extraneous variable at the alpha side. So AB tends to C. We will take this. So according to our first rule, what you have to do? Alpha minus A. So what is extraneous here? I am going to take B as extraneous here. So I am going to calculate whether B is extraneous or not. Whether B is extraneous, we are going to calculate. So if B is extraneous, so what do you have to substitute? Instead of A, you have to substitute B here. So alpha, what is your alpha? AB minus B. So here B plays the role of extraneous variable. So A is given as extraneous. So A, so now you have to calculate A closure. So from the given set of functional dependency, when you see that A tends to BC, so what is your beta side? It's C. You are able to get C if you remove B from your functional dependency. So the functionality is being preserved here. So B could be an extraneous variable. So B can be removed and can be written as A tends to C. Okay. So this is for considering B is extraneous. Suppose I consider A as extraneous. Then you will get B tends to C. Of course, you have B tends to C. If you calculate attribute closure for alpha, that is B plus, you can see we have a functional dependency B tends to C. Anyway, you are getting C. So if you remove A also, still the functional dependency is being preserved. So it is our decision whether remove A or B. Both, if you remove any one also, the functional dependency is being preserved. So next we are going to see about the beta side.